I'm going to talk basically about data and cognition, right? So dynamic data visualization will be like the solution or the answer to the problem of creating a meaningful connection between big data and people, cognition, okay? So that's pretty much. I'm going to show a lot of stuff, basically work of mine, work also done in my team. Moebio.com is a sort of laboratory, is also the research team from Droneway, which is the company I recently co-founded. And this is where we explore, try, invent different devices, approaches to enhance, to make more interesting interfaces in the most general definition. So communication in ways that are meaningful and, as you will see, dynamic. Because the main thesis is that deep insight happens in movement. It's not static. And it's not one shot. It's not, here's your data, and then I produce a series of interesting analytical results and visualizations, and then I have that, and I go and make my decisions and produce some actions. It has to be dynamic, exactly the same way humans interact among them and extract knowledge one from each other. It's in conversation, right? So that's why the dynamic aspect is very important. Okay, let's go. Data and cognition, basically. I'm going to take two quotes from Alicia's very interesting presentation. When data becomes information. There's a lot of data, but at some point it has to carry some meaning. And this is the process in which data and people connect, data and minds connect, right? And this is the process I'm going to talk about. Also, we have this phenomena, also commented by Alicia, that overinformation is, in essence, the same as hiding information. As the Zen proverb says, the best way to keep wet a drop of water is put it into the ocean, right? The same happens with information. So part of extracting the pieces of data that are meaningful and that builds information, it's also extremely important, and that's exactly what our brains, along with our perceptual systems, do all the time, right? We are basically invaded by overinformation, but we have this machinery to extract what we believe is meaningful, right? So this is pretty much the main topics I'm gonna touch today. It's gonna be a little bit disorganized, multiple things. I'm gonna point in multiple directions, but the important thing is, with all these examples and ideas, I am building on top of a general strategy to connect data and cognition. Okay, so one of the most, there are two main very important relations between human cognition and the field of artificial intelligence. Two ways in which these two areas interact, and their academic areas behind, which is cognitive psychology and then artificial intelligence as a research. One very important and very interesting, which is also historical, is how one has inspired the other along the last, let's say, 50 years. Since the beginning, since the beginning of cybernetics, the artificial systems have been imitating what psychologists and more recently neuropsychologists are learning about our brains, our minds, our behaviors. But the other direction is also valid, especially more recently, psychologists are looking into what those artificial systems are doing, because in a way, the success of certain particular systems over there validates certain models we also have about our minds. So there is a feedback loop, very strong feedback loop between these two. Then, in the other way these two systems are related is on interaction, right? These artificial systems interact with humans. and humans interact. And these two are strong enough to keep both always in mind. Whenever we think in one, we have the other as a sort of shadow, okay? I have this idea that I've been also exploring is very important in the work we do, that in a way we are all data scientists, but for many reasons. Our brains, as I explained, work with models, but also even at a more conscious level, we all the time use heuristics that resemble certain machine learning algorithms, such as, for instance, decision trees. This is something we do all the time. And one thing I do is I use my two kids for all sorts of crazy experiments and put them to, one idea I have is that I can teach kids data science, right? And in this case, it's a very nice algorithm called KN neighbors, right? K neighbors. And they are basically doing that. They are deciding, it's a classification problem, they are deciding for the circles that are not colored, what is the color, right? What is the natural color? And in some cases, it's very easy for certain circles, right? In others, it's more problematic. If you keep the kids playing that game, at some point, they're going to identify the problematic ones, and maybe at some point, they're going to start producing heuristics to how to solve, because they know that just intuition could produce errors and inconsistency. And they start thinking, okay, let's create a rule for that. So we don't have to think. It becomes a no-brainer. Let's count the neighbors. And they, at least with certain assistance, they get to produce or to, in any case, to understand very well the idea. And this is just one common algorithm. There are many others, and it's fantastic to see that kids, in a way, our minds already come prepared for these kind of processes. And this is very important for my objective, which is create systems that humans can use, understand, interact with, okay? So I have this model, let me see, okay, that basically starts here, or ends here, but for me is actually the starting point, because it's the human side. Data flows starting in huge organization, data silos, is very hidden, is huge, is very difficult to extract, etc. So there are certain processes, more or less technical, that try to put this data closer to the humans, right? And these processes take data from silos, organize these huge data sets in distributed databases. Then eventually, some parts of that data, or eventually even some aggregations or samples or analytical results are also available in servers. And then you have systems such as APIs that produce all sorts of requests on those servers, and the data start arriving to the client, to the devices. And then, at least in my case, because the visualization I produce, they work on the browser, the data has to go to the browser, then the data has to become an image or text, so it is perceptible, and then the senses capture whatever appears in those screens, and then that goes to our mind. The important thing is, in this flow, the size of data gets narrow and narrow. The size of data gets narrow and narrow, and also the size of information. But what is important is the proportion should be increasing. So every time we narrow down the absolute amount of data, the absolute amount of information will also narrow down, but is lower than the speed at which data decreases. That's the idea. So that's extracting information from data. But the thing is that if this was just one single path, one single journey of the data, it will be very poor. What happens is that our minds process this data and then start interacting, right? So it becomes an active system. It becomes a dynamic system as well. And then you move, you navigate throughout the visualization, if the visualization allows you to do that, and that's the reason I talk about dynamic data visualization. And you, from the image itself, or from the multi-image, you start extracting more and more information from the same data. But at some point, it's not enough. And you want to explore further, or deeper, or move in certain dimensions, such as space or time, or maybe it's a semantical dimension. Then you do a request. This is a very thin piece of data that goes back to a previous node and brings more data. So you see there are multiple feedback loops over here. The quality, the architecture of these feedback loops guarantee that I'm going to extract as much as possible information and value from the original huge data sets over there. Okay? Also, all these nodes, these different repositories of data, work collaboratively. So, for instance, humans, when they interact, they collaborate. Humans, basically, it's collaboration and culture, right? But devices, as we have seen, also collaborate and communicate. This is the Internet of Things. But then databases also collaborate and communicate. This could be distributed storage and computation. And now I realize there is a node here that is missing from the initial presentation today. We have a universe that contains data, but now we know how to communicate all those universes, also to make distributed computation. That was the quantum computation presentation in the morning. So even universes can collaborate. So this is the framework we have for dynamic data visualization, this conceptualization, and this is the kind of stuff we actually deploy and produce. Let's go more in the side of the humans then. Memory. I'm going to be very fast on this, but this mnemotechnic based on first memorizing 100 numbers and associated each number with an actor, an action, and a passive object. Okay? If you do that, you're going to have at least with 100 items or situation, 3 of which could look something like that. And then you also create things that are easy to memorize. So for instance, the number 10 is easy to associate to Leo Messi. And then I imagine Leo Messi kicking a ball, right? This is number 10. 45 is an atomic bomb blowing up a city. Okay, you understand why I choose the number. For 69, I had a lot of options. I decided to use astronaut stepping in the moon. Okay? So again, object, right? Actor, action, and passive object. I already did that with 100 objects, and this is the only thing I memorized. Now, if for some reason I need to memorize a 6 figures number, what I do is I go back to my memory. For the first 2 figures, I search the object. For the second 2 figures, I search for the action. And for the last 2 figures, the passive object. So what will be the story here? Who's 10? Messi. What is the action of 45? Blowing up. And 69? So now imagine what happens with these 6 figures. Put it in your mind, right? It's going to resemble something like this, maybe, right? And the nice thing is that this you won't forget never. I guarantee that, okay? So if I have a string, an array of numbers, a very long number with a lot of figures, I split in blocks of 6. And what I do after that is I create a palace of memory. I place these kind of situations all over a sort of path in a memory I have of a house, for instance. And then you can start memorizing very long sequence of numbers. The important thing is that machines use numbers for storing all sorts of information, including stories. And we need stories to storage numbers. And this is the yin-yang of machines and humans. The moment you start to understand the inner logics of those two systems, how they communicate, you can produce magic. So one of the key aspects is that visualization is a language. That's one of the aspects of defending visualization as or at least potentially as a dynamical activity, right? Not just some static production that is objectively tied to the data. We're going to see is not the case. It's really a language, and it's as dynamic as language is. So some arguments for that is that it contains typical properties of languages, such as it has productivity, it is generative, it is combinatorial. Let's see a little bit of that, just for the sake of the argument. This exercise is fantastic. I've done it a couple of times in workshops. You give a group of people two numbers, and collaboratively, you start thinking of ways to visualize these two numbers, right? Let's take into account like writing systems as a visualization system, because they are, okay? So this is actually the first that comes in mind. But there are others for sure, right? 75 and 37 could be visualized in a very obvious, direct way, like item by item, right? Then eventually, as it happens, these numbers could refer to entities that actually exist. So you can use icons. So you are playing with the techniques you are using for visualizing, right? Then eventually you can come with clever rules, right? To grouping, etc., to structuring. These are more or less heuristics, conventions, standards. Then it depends on how you see the data. It could be more about distance, or even if it's not distance or size, you can associate this geometrical perspective, even if it's just quantities. It could be age of two people. Even so, you can use bars, right? Other sort of visualization devices, percentages, because these numbers could be percentages. Eventually, it could happen that these two are parts of a whole. So this makes sense. Makes more sense that put each number in a separate visualization, right? Or even one could be part of the other, right? Or it could be the start and the end, etc. So I'm going to move faster now because the possibilities are actually endless and sometimes ugly as well. Different ways associated to area instead of length. We know it's very problematic. It doesn't matter. The thing is that there are many ways. Again, going back to metaphors, eventually wrong metaphors, right? Because if we are not talking about weight, this metaphor doesn't make sense. But you're going to see in visualization a lot of very cognitive dissonant metaphors being used all the time, right? Sorry. I'm going to continue faster now. So this is where we were. Colors could be used, proportions, etc., etc., etc. So it's really infinite. This is just a list of visualization that could be produced. Eventually, some movement because it's frequencies, even sound. The list can continue growing. And if this happens for two numbers, imagine a list of 100 numbers. Imagine you have text, categories, numbers, geographical coordinates, everything talking about the same actors. Is really infinite combinatorial and is never an objective rule that associates data with the visualization. It's human work, always. Its interpretation is loaded with metaphors, with narrative. It's impossible to dissociate one thing from the other. This, I'm gonna show an experiment in the data beers with this beautiful idea. In this case, I go back to the writing system, but it also has the area property. So the surface of these figures are proportional to the figures themselves. So the amount of black ink for the 75 is really proportional to 75 compared to the square it occupies. Okay? It's a beautiful invention. It's not mine, unfortunately. Okay. So combination, infinite things. Now, the important things. For this, I mean that you can use visualization to talk not only about, not only for visualizing metrics of a company or statistics. You can use visualization for expressing many, many different realities. So I did another exercise, which was basically ask people what they think are the important things in life in general. And I just curated a list of words. And these are just words. So universe, colors, movies, cities, friendship, trade, opinion, influence, family, music, art, study, history, weather, planets, stars, etc., books, science, religion, etc., genes, evolution, names, food, war, death, and life. 30-something words. And then I explore, I am very well organized, like keeping a lot of references from internet. I explore my references. I did further research, and I found a visualization, a very good, interesting, and probably also interactive visualization associated with each concept. Just to show that indeed visualization, not only it's vast in terms of the different methodologies or geometries you can use, but also realities you can address. I'm going to play a little bit with this in the data beers. Okay. For universal, I mean that I really believe, as in the case of the data science processes, that visualization could be eventually something very natural in humans. It's something that can happen, this connection between eye and hand and ideas. So as a matter of example, this was created by a 10-year-old kid that has never hit her toe, at least, heard the word visualization or something of the sort. This is his Avengers comics, and he has been charting how much he finds interesting a character a long time, or in different books or magazines, right? And this is very avant-garde, because it's not just that it's a nice visualization, very spontaneously produced, but it's not just visualization about something that happened on the magazines. He's visualizing his relationship with the magazines, subjective visualization. So data about what he likes, what he prefers in different times of his life. So again, my kids, obviously in that case, I give them a lot of ideas and tools, but they very naturally also produce this kind of stuff. So I predict that in the future we're going to see visualization becoming something normal in our culture. Like it's actually it's another presentation, but I also have arguments for saying that data and visualization is going to be a new cultural industry, really. Okay, it also tells stories. It's language, so it has to be able to tell different stories. Here I took a book I love, which is Rayuela, Hopscotch by Julio Cortázar. It's a book that itself is, let's say, data-driven or has some data structure behind it. You can read it linearly if you want. The author tells you can read you can read this book linearly, or if you want, in each chapter you're going to have a proposal for jumping to another chapter in the book. So you can also have this other. And the thing is that it's so complicated, so entangled, that I believe really that what Cortázar wanted is readers to be lost. At some point, you're going to make an error, and you're going to start reading another book that anyone had read in the past, right? It's a sort of intractable problem. How many books are in this book? It's kind of an intractable problem if you want to actually produce all the possible books. It grows very fast, right? And then if you study the topology, there are sort of tricks and traps over there, like certain chapters that in the second way of reading you will never reach, or finally a loop. So it's like the author killed the readers because they are trapped. They will never go out of the book, right? But more than visualizer, I also wanted this sort of device to be the book itself. So you can read it, you can use it. If I click on a chapter, I can go and actually read it, continue consecutively, or follow the jump suggestion, etc. So Books like this one are many, and I actually visualize many books. It's one of the things I love to do, such as the I Ching. It's a very beautiful book in that it's also very nonlinear and very playful, right? And there are many others with strange and natural. This is also modernism, right? Western modernism, this kind of games, this kind of meta-explorations, etc. This is more on the side of television than books, but it's also about telling stories and narratives. From a Fempedia of the Lost TV series, I downloaded, I grabbed all the scripts. They were very well organized, so I could actually parse the scripts and create a visualization that in a way resembles somehow like a comic book. You can read it. I actually read a couple of chapters of episodes, and it's readable. You can follow the story just by the picture and the dialogue. It's interesting. But this is, and as you can see, it's kind of a lot of stuff here, because it's 7 seasons. It started with 2 great ones and then going down in quality, you know that. Okay. Nonetheless, I stay until the last chapter. I was loyal, okay, with the series. But more interesting, perhaps, is the nonlinear aspect, such as if you look at one single episode, what are the connections? Also very easy to extract just from the data. From basically, the connection is strength whenever 2 characters participate in the same dialogue, basically, right? And the sphere here maybe serves as a metaphor of the island. They are trapped. And then you can jump from one chapter to the next one and explore a little bit the dynamics of the topology of the network, maybe the adjacent matrix perspective. And this is kind of a game of 2 ways to visualize the same data. It's a typical decision, the adjacent matrix or the graph, right? Both allow to look into different aspects of the data. Actually, in this case, I learned more with the adjacent matrix. So you go to the intersection, and you can actually also look into the relationship between 2 characters along the whole series, etc. And finally, a trick we use a lot, and I want to place a comment here. All the projects I'm going to show today are basically experimental research, etc. But we are using all the same techniques into projects we deliver to corporate clients, basically. So they seem kind of crazy, very playful, very experimental, but they are being used because this is how we explore the connection between data and minds, right? And then we learn a lot, and then we use it into our solutions products. So reenactment, we use that a lot, which is take the data that in a way expresses something that happens in time and make it happen in time again, maybe at different time scale. But again, you can maybe a little bit slower. You can follow an entire episode this way. I've done it, and you can follow it. It's readable again. It's like reproduce the chapter only from data, right? This is the process of from television to data. You reduce the amount of data by a huge factor. Imagine all the information, all the data that the video has. It's way more than just the script. But then, intelligently or with some criteria for curation, you select certain images, just the scripts, and you can extract a lot of information from a very critical piece of data, right? To the extent that eventually this doesn't feel so different in terms of narrative that actually looking at an episode. Okay. Now, not only dynamic data visualization could tell stories, it can also express knowledge, right? Which in a way is similar to stories, but probably what is different is the structure. Maybe the metaphor for a story is more like a straight line, something that is sequential, whereas knowledge is more vast and expansive, more like a landscape in terms of metaphor. So in a way, you expect people that are exposed to knowledge data, whatever that is, to be able to explore, right? and not just to be only able to reproduce the story or the multiple stories contained in the data. Before showing a couple of examples on data that is loaded of knowledge, I'm going to show this little experiment here. It's a 7 sets Venn diagram. Okay. I didn't discover the topological object, but I did reconfigure the geometry respecting the topology to create something in which areas of all the intersections are basically similar. And you have 7 colors. So you can mix any subset of colors. So the number of combinations, it's, again, this is very connected with the conversation this morning. It's, you can think of a universe as a color here. And then there are all sorts of possible combination and calculations that could be done. So this one is a set, is the blue set. And you see all the other sets have exactly the same shape, just rotated 1/7 of the proportion of the whole circle. And all the possible combinations are represented here. You have in the bottom the legend of the combination of colors and what they did produce. This is the resultant colors are compared against a very big data set of color names. So I can extract those names, etc. And you can also see this from the other side and see the colors they produce. But this is a sort of object that contains, well, combinations. But if instead of colors we had concepts, ideas, you could start combining ideas. Or for the machine learning people or the artificial intelligence people here, sometimes you have features and you don't know which subgroup of features are the best predictors, right, for a certain task. This is a sort of device that explores all sorts of combinations. We use that in machine learning context, at least in the ones we can isolate 7 good feature candidates, and we use this to visualize all the combinations, and then we color by the accuracy of the model, for instance. So it's a game of combination, but let's go back to this original idea of knowledge, information that somehow represent knowledge. So let's imagine this being big conceptual categories. So I mentioned that I'm very organized with my references in internet. I started using Delicious many years ago, then I switched to Pinboard recently, but I have thousands of references very well tagged, right? And then with an algorithm that basically explores my tagging system, I use around, I don't know, let's say 30 main tags, and then tags that are very exceptional. But this algorithm, what it does, it combines all the tags and explores which subgroups of tags contain the most information using information gain, okay? So you compare two tags, and when you subdivide one tag with the other, you see how much you reduce entropy. That's basically the process. With that criteria, I found like 7 big groups of tags, and then I manually changed the name of those groups. And the result is then, I say this because it seems that 7 is a very arbitrary number for classifying or for combination. But there are ways to start with something that is not 7 and go to 7. It's arbitrary, but we all agree that 7 is the best number on the universe, right? So it has to be 7. When I was building this, I searched for nice esoterical color theories in the 18th and 19th centuries. And there is one also associating colors with emotion, but it's based on 8 different colors and emotions. And my thinking is, who can make a system based on 8 instead of 7? What a awful decision. Okay, I was really touched by that. These are all my references, and now these are the big groups: are interface, art, networks, humanism, technology, language, and science. This is how it found the most it reduces entropy and finding the best subgroups, right? And then this central part here is very serendipitous. It's meant to allow like random discoveries or also associations. So I can see that there are contents that are, for instance, Wikipedia pages that are close one to the other or on the same subgroup that I never thought could be connected. So it's also a device for finding interesting new connections. You see the set in the center has very few items. So very few items actually are tagged by all the tags at the same time. These are the interesting ones, or some of the most interesting ones. Whereas science is the one that has the bigger number of isolated contents. That means they are tagged just by science and not by any of the others. But the interesting ones are probably somehow in the middle of the belt, right? Like our planet in the galaxy, somehow here, not exactly in the periphery, but a little bit closer to the center. And then there are all sorts of more rational tools for navigating, searching time, by category, by type of content, decided which subgroups or tags I want to use as or as an and, etc. So it works very well. Exclusive, now let's see the or. So if I zoom in and I look just into my last tags or maybe into the early ones, into the early content, sorry, this kind of thing. Now, this is individual. It's my work of organizing my research, because finally this is my research for the last 15 years. All the resources, all the contents, all the interesting posts, papers, videos, projects, a lot of projects, my own projects. So I put my own projects here in context, so I understand my projects, where do they live in a more vast universe of cultural production. But we are using in our tools something that is, I believe, more interesting. Something similar to this, not as esoteric or as does not behave that crazy, but it's more interesting because it's for groups of people. So basically the same idea, but it's collective. So you really have a collective kind of brain in a way. Obviously, it's just references, but when references are connected, meaning starts appearing. Okay, good. This is a project. This time is not just me. Is the whole Moebio team working in a project for an institution that has several schools around the world, especially one in New York. They have a completely new, different approach to education, especially in terms of the contents, the pensum, and in particular how it is structured. So they have this big metaphor of the spiral, right, in which kids grow and navigate the spiral, and when they do that, they go back to the same subjects, but they look at them from a different perspective every time, and they connect once and again, with an incremental level of complexity. So they understand humans as incremental, and then they go back to history, to human history, and they make an association between human evolution and individual evolution, which is something that many people have thought. So these are ideas that are not per se original. This idea of the spiral as a metaphor of human evolution belongs to the 19th century, and the idea that individual evolution resembles our species evolution, also incremental complexity, also in the way we interact with others, etc., is not new. But here, the whole pensum is structured very well, and it puts a lot of emphasis in connections between contents. And there are different ways in which connections could happen. For instance, if I go to a certain grade here, I will see there are these little spheres floating in the air. These are projects that connect different learning experiences. So learning experience is the minimal piece of data in this data set. It has a text, certain images, is the minimal content, is the data point. And a project like this connects multiple learning experiences and this is how they work. So they go back to whatever they have learned or what they will learn, probably even in a different grade, and they create experiences and projects based on that. There are also the threads that navigate throughout the whole spiral. So if you follow a thread, you can start in the bottom, so the lower grades, K in this case, and basically continue navigating. Let me check. If I select this one, yeah, start here, and then I go here to navigate the whole thread. So this gives an amazing perspective for the students, parents, teachers about how this subject will be resumed or addressed again in other grades, and how different subjects are being completed in different ways. So this is not just a visualization, it's also a tool to be used in classroom. That's how it is used. It's a tool of communication. It's a tool of exploration, again, serendipity, kind of experience as well. So this is one of our most complex projects in terms of visualizing knowledge, and we are happy with the result. Okay? These are all the units. Units are made out of different learning experiences, so you can navigate linearly. There are other metaphors about human evolutions. So the arithmetic mentality, followed by the geometric mentality, algebraic, dynamical, and complex dynamical, which will be the times we live on. Right. Okay, so now the concept of the dynamic data visualization, I think it's clear, if only from the examples. There is dynamism placed in different ways. Very important is the perception, cognition, action, reaction loop, a very fast one. So you see, you understand, but you want to move yourself or move this space around you in terms of data, and you act on that, and it changes. And it changes, and you get new stimuli, right? And if this loop is fast enough, you start building and extracting information and value out of the data. Very fast, very fast. And very important, data in a session time can only grow linearly. If you spend the double of your time interacting, you will get the double of data, right? It's how much your browser can load, or your connection, and how much you can visualize at any given time or place on the screen. But information grows non-linearly, because information lies not in the accumulation of data points, of pieces of data, but in the relations. And then value, which is another layer or another dynamic, it's also non-linear and discontinuous. It's when you accumulate enough information, you suddenly understand something more deeply. Or you gather enough information and understanding to make a decision, for instance. So it jumps, value jumps, works differently. This is the kind of models we have in mind when we create dynamic data visualization. It's multidimensional, so it's not, in visualization, we are very much used to graphs and scatter plots. Those are certainly great for certain uses, but look what happens. You take the data that is extremely rich in dimensions, in types. You have geographical information, you have dates, you have numbers, quantities, categories, and you isolate pieces of your whole data set, or maybe multiple data sets, and you visualize each individual variable, or maybe a couple of variables. So it's a reductive process. Dynamic data visualization is basically the contrary. It's about putting in connection multiple variables in different ways and try to extract value from the combination those variables produce. It's multi-scale. You have seen also in the examples, it could be even eventually geographical or geometrical scale, but sometimes it's also semantical scale. You got into the detail around some subject or certain range of values, etc. And it's narrative, it has a structure, because it follows human processes. That goes back to how we memorize numbers using stories. If it has temporal structure, how we are in connection with the data follows a story. Even if it's not an evident story placed there, you are living your life. So it's a story in a way. So if you take into account that the accumulation process and the direction you are moving, it is narrative. Okay? I'm going to finish with the very last example on what we call visual data science. Very fast, we have 500 biggest companies. I'm going to select some randomly, and you can visualize basically 2 dimensions here, right? So in that regard, it's very reductive. X-axis is revenue, Y-axis is taxes. And different companies have a different story. Here you see the story because you have time, and you can even try to imagine what happened with some of these, right? Why this huge motion? Here in the right, what we have is we extract the pattern. So we don't care about the quantity itself, but more about the movement, right? And bulk corporation is getting lower revenue in time, right? For these last years, you can look into a longer time period. But let's focus on 3. Whereas $3 goes in the opposite direction. Are there other companies such as $3? Let's click $3, and it finds other companies similar in pattern, not in quantities. We look into the pattern. This is another characteristic of dynamic data visualization. They are hugely different, like orders of magnitude different. So no one maybe had already compared these 2 companies because they never thought they were actually comparable, but they have similar patterns. Maybe the story behind is similar. They moved to Ireland and started paying lower taxes. Who knows, right? Now, imagine I have in mind some kind of progression or pattern, and I would like to find something like that. I can draw it. And this is when communication between mind and data start becoming more interesting. So this kind of analytical processes that run in real time is what we call visual data science, and we do that with more sophisticated models as well, not just this very simple pattern search. And it has a fantastic future. So I actually believe the fusion of visualization and data science, and not using visualization just as the method to communicate the results of the data science or all the modeling process, but actually integrated is a door for integrating as well human cognition and machine capabilities to make them collaborate more fruitfully. And with that, I'm done. Thank you very much. Gracias. Questions?
Thank you, Santiago. I think we have time for 1 question at least before we head off for beer and pizza.
Well, Santiago, congratulations, because your visualizations are just amazing. And so I feel the need to ask you, what tools do you use to develop your visualizations?
So more a little bit about the tools and the technology. Yes, it's everything runs in the browser. Is basically JavaScript, but it's a framework we produce on JavaScript. So some people might know D3. This is not D3. It's Moebio framework, and we call that way Moebio framework. It has a different logic. It has a logic that goes directly to those concepts I presented here. And it uses the canvas, not SVG objects, because, well, I could spend a lot of time explaining why this decision, but in a way, if you have control of every single pixel, is the most interesting way to match data, image, and cognition. This is how we see the thing. So that's why we took a different path, very different from D3, and for the kind of stuff we do, it's actually better. Also for the amount of data points we visualize and the movement we want, it's not just objects that are placed in different, that are put in different places in the space. As you have seen, there is deformation, there is topology, there is non-linearity on it all the time. So it's a framework prepared for that. It's created by us. We have other tools that we use. Also, our framework has a lot of machine learning on it. And machine learning that is available to be used in real time all the time to be integrated into visualization.
Thank you.
Okay. Will you be around for more questions after this?
Actually, I invite you to go to the database if you want. There's going to be like 4 or 5 presentations. I'm going to be among them. Yeah. So, and then I will be here. Yeah, absolutely.
Great. So thank you all for attending today, and let's give another round of applause for Santiago.